1.3 goes over lines. We're going to be working with slope of a line, point slope formula, standard formula, as well as slope-intercept form of your equations of a line. So in order to find your slope, you're going to be given 2 points, and you're just finding the rise over the run, which is the change in your y values over the change in your x values. So you're going to take your y2 minus y1 and put it over x2 minus x1, and then just simplify your fraction as far as you possibly can. With your slopes, you have different types of slope. You have a positive slope, a negative slope, a zero slope, and no slope. So when you have a positive slope, your slope is going, or your line is moving upward from going from left to right. You have a negative slope when your line goes downwards from left to right. A zero slope is a horizontal line, and it has a slope of 0. And then your no slope is one of those undefined slopes when you have 0 in the denominator of a fraction, and that's just a vertical line. With your zero slopes, you have an equation that is y is equal to a number, and then your no slopes, your undefined slopes, you're going to have an x is equal to a number for your equation. There we go. So with these, our no slope is that undefined slope. So that we said was a vertical line, and it goes through the x-axis, so it's an x is equal to a number. So when we look at this question, for our first example, we're going to find the slope of the line that passes through the points 2, 1, and 8, 5. So we have these 2 points. We're going to use our formula for slope. So that's y2 minus y1 over x2 minus x1. So I'm going to label my p as x1, y1, and my q as x2, y2, and just plug these values in and simplify. So if y2 is 5, I'm going to have 5 minus y1, which is 1, over x2, which is 8, minus x1, which is 2. The 5 minus 1 gives us 4. The 8 minus 2 gives us 6. And 4 over 6 simplifies to 2/3. So our slope is just 2/3, which means if we are starting at one point on our coordinate plane, we are going up 2 places and then to the right 3 to plot our next point. Eventually. An equation of the line that passes through one point and that's your slope is given to you can be represented in your point slope form of a line. You're just taking y minus y1 is equal to m times x minus x1. So for example, if you're given the point 3, 4 with the slope of 2/3, the way that we would input this into our formula would just be y, we would keep, minus y1, which would be the 4. The x1 would be that 3, so y minus 4 is equal to your slope, which is 2/3, times x minus x1, which we said was 3. And then we could literally leave it like this and then be done with our equation. For our second example, we are finding the equation of a line through the point 1, -3, and a slope of -1/2. So we have the point 1, -3, and our slope is -1/2. So our x1 is the 1, and our y1 is the -3. We're going to plug it into y minus y1 is equal to m times x minus x1. From here, we're going to have 1 minus -3 is equal to -1/2 times x minus 1. So I just plugged my values in, and now I'm going to simplify. Whenever you have the two negatives next to each other, they turn into a positive. So this turns into y plus 3 is equal to -1/2 times x minus 1. So this is your equation of your line. For our next part of our lesson, we're going to look at what slope-intercept form is for our equation of a line. Slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept. B is always the point 0, comma, something. That something is what you put in place for b in this equation. When you're doing this, it's very easy to just take that b term and plot that point on your y-axis, and then use your slope to either go up or down and to the right in order to get your next points. So vertical and horizontal lines, an equation of a vertical line, so a line that goes up and down, is always going to be x is equal to a number, just like we said when we looked at your slopes. So anything that you have that's a vertical line has a slope of 0. With an equation of a horizontal line, so those ones that go side to side, it is going to be y is equal to a number, and those slopes are undefined. Hold on, let me go back. X is, yes, slope is 0. I just wanted to make sure that So if you look here, it says that an equation for a vertical line through the point 3,5 is going to be x is equal to 3, because the y value doesn't matter. We take the x and we just set it equal to x. So x is equal to 3. The graph of the equation x is equal to 3 is a vertical line with a y-intercept of 3. Since it's a vertical line, then we have that slope of 0. Gave that to you correctly. Okay, so with an equation that you have a horizontal line for, that goes to the point 8, -2, that's where y is equal to -2. It's a horizontal line, so it goes through the y-axis, which also means that your slope is undefined, and here your y-intercept will be the -2. You will not have an x-intercept if you have a y is equal to a number, and you will not have a y-intercept if you have an x is equal to a number. Slope. The general equation of a line for a linear function is ax plus by is equal to c, or ax plus by plus c is equal to 0, where a and b are both non-zero numbers. You also, when you are putting it into standard form here, which is also what this is called, you will not have a fraction in front of a or b. So they have to have whole numbers in front of the a or b. So the coefficients of a and b, or sorry, the coefficients of x and y are whole numbers. Explanations. So parallel lines are two lines that will never intersect one another, and they have the same slope. Your perpendicular lines, however, have the opposite and reciprocal slopes. So when we look at our next example, we're finding an equation of a line through the point 5,2 that is parallel to the line 4x plus 6y plus 5 is equal to 0. So this is giving this equation to us in standard form. When we give the equation of this line that's parallel to it, we're also going to put that equation in standard form. So we're going to start by finding our slope. So we have 4x plus 6y plus 5 is equal to 0. The easiest way that I find to find our slope is to rearrange this formula into slope-intercept form. So we would move that 6y by subtracting it from each side to get it by itself. And we're just going to have -6y is equal to 4x plus 5. And then we're going to divide everything by that -6 to get y by itself. And we have y is equal to -2/3 x minus 5/6. Now, if our slope is the same and we're working with parallel lines, our slope for this new line is going to be -2/3, and it goes through the point 5,2. So what I'm going to do is I'm going to use my point and my slope and plug these values in to my point slope form. So when I do this, I'm going to have y minus y1 is equal to my slope times x minus x1. So I'm just going to plug these values in. So I'm going to have y minus 2 is equal to -2/3 times x minus 5. from here, I'm just going to distribute in my negative 2/3 because, again, I want my formula in standard form because it's given to me in standard form with my first line. And I'm going to have y minus 2 is equal to negative 2/3 x plus 10 over 3. I want to get rid of my fractions. So I'm going to multiply my entire equation by the least common denominator of all my fractions, which in this case is 3. So I'm going to distribute this 3 in and multiply it by each of these 4 terms within this equation. So 3 times y is 3y, 3 times negative 2 is negative 6, 3 times negative 2 over 3x is just negative 2x, and 3 times 10 over 3 is just 10. So from here, I want my x and my y to be on the same side. My x has to be positive, and my constant has to be on its own side. So I'm going to move this 2x over by adding it to both sides. So I have 2x plus 3y minus 6 is equal to 10. Now, since my equation that they gave me is equal to 0, I'm going to make sure this equation is also equal to 0 as well. And I'm just going to subtract that 10 from each side to give me 2x plus 3y minus 16 is equal to 0. And that's the equation of my line that's parallel to the line 4x plus 6y plus 5 is equal to 0. For our next example, we're showing that the points P, Q, and R are the vertices of a right triangle. By doing this, we're going to take P and R and find the slope of those, and then take the slope of Q and R, and see if they are opposites and reciprocals, because parallel lines form a right angle because they intersect at a 90-degree angle, and in a right triangle we have 2 lines that form a 90-degree angle. So we want 2 lines that are perpendicular to each other. So perpendicular lines are opposite reciprocals. We're going to start with P, which is 3, 3. And R, which is 11, 5. We're going to find the slope of these. So I'm going to do y2, so 5 minus y1, which is 3, over x2, which is 11, minus x1, which is 3. Our 5 minus 3 gives us 2. 11 minus 3 is 8. 2 over 8 is 1/4. Now I'm going to find my slope for Q and R. Q is 817, R is 11.5. So I'm going to do y2 minus y1. So I'm going to do 5 minus 17 over x2 minus x1. So 11 minus 8. 5 minus 17 is negative 12. 11 minus 8 is 3. So that's negative 12 over 3, which is negative 4. Because these 2 slopes are opposites and reciprocals, these 2 lines form a perpendicular relationship, so they do form, these vertices do form a right triangle. So some extra examples that we are going to look at. For 25, we have an ordered pair that's 2, 3, and a slope of 5. We're putting this into point slope form, so we're finding the equation of this line. So this is just going to be y minus 3 is equal to 5 times x minus 2. For 27, we go through 1, 7, and we have a slope of 2/3. So again, y minus y1 is equal to m times x minus x1. So this is going to be y minus 7 is equal to 2/3 times x minus 1. For 30, we go through -1, -2, as well as 4, 3. So this one does not give us our slope. We have to find our slope. So we're just going to do y2 minus y1 over x2 minus x1. So 3 minus -2 over 4 minus -1. Those two negatives will turn into positives. So this is going to give us 5 over 5, which is just 1. Now, when you go to give the line for this and you put it into point slope form, it does not matter which point you use. Typically, we'll use the one that has the lesser of the negatives there. So instead of using the -1 and the -2, because then we'd have to change signs, I would just use the 4, 3 as well as our slope and put it into point slope form that way. So we would have y minus 3 is equal to 1 times x minus 4. From here, if you wanted to put it into standard form, you could do so. You would just move the y over by subtracting it from each side, so that way x stays positive. So x minus y minus 4 is equal to -3. And then we can just add the 3 over to get x minus y minus 1 is equal to 0. So again, it's totally up to you. I would use this up here for my point slope form. And then if you wanted to use the -1 and the -2 instead, you could do that as well. You would just have y plus 2 is equal to x plus 1. For 37, we go through 2, -1, and our slope is undefined. So if our slope is undefined, we want to try to remember which line that is. So we can look back at our undefined slope. We have an ordered pair that goes through 2, -1. If it's going through the x-axis, it's just going to be x is equal to a number, which in this case is the x value of that ordered pair. So it's just x is equal to 2. For 39, we are going through 1, 2, and it is parallel to the line y is equal to 3x minus 5. Remember, if it's parallel, it has the same slope. So our slope here is 3, and it goes through this 1, 2. So use your point slope formula. Y minus 2 is equal to 3 times x minus 1. For 40, we're going through the point -3, 2, and it's perpendicular to the line y is equal to -1/2 x plus 7. If it's perpendicular to this line, then our slope is going to be the opposite sign, so it's going to be positive, and the reciprocal of 1/2. So it's just positive 2. We use that with our ordered pair. We put it into point slope form. We have y minus 2 is equal to 2 times x minus -3. You can't have two negatives next to each other, so this simplifies to be y minus 2 is equal to 2 times x plus 3. For 43, we're going through the ordered pair 1, -6, and it's parallel to the line x plus 2y is equal to 6. If it's parallel to this line, it has the same slope, so we're going to get y by itself. We're We're going to just move x over by subtracting it from each side. We have 2y is equal to negative x plus 6. We divide everything by 2. So y is equal to negative 1/2 x plus 3. Our slope is going to stay the same as this since it's parallel. So our slope is going to be negative 1/2 with the ordered pair 1, negative 6. So this is going to give us y minus negative 6 is equal to negative 1/2 times x minus 1. Simplify this because we have to put it in standard form. So the two negatives next to each other turn into y plus 6. We can distribute the negative 1/2. This is going to give us negative 1/2 x plus 1/2. We then want to get our x and our y on the same side, and x has to be positive with a whole number coefficient. So we are going to multiply this entire thing by our least common denominator, which is 2. This is going to give us 2y plus 12 is equal to negative x plus 1. We want a positive x, so we're going to move this x over by adding it to both sides. So we're going to have x plus 2y plus 12 is equal to 1. From here, we just move the 12 over by subtracting it from each side, and we get that x plus 2y is equal to negative 11.